If you're like me, it's likely you're going to just make a stupid mistake when you're doing integration by parts, especially when you do it multiple times. Like in this problem, we're going to have to do integration by parts multiple times to solve this integral. So let's see if we can find a better way. This is going to be a tabular way. So first off, let's identify what is our u and our v. Here's u and here's v, right? Because the integration by parts says this is going to be uv minus the integral of v du. Now that we've identified u as x squared, let's just take a bunch of derivatives till we get down to 0. So 3x squared, 6x, 6, and 0. Now that we've gone through all of those, let's find all of the dv's, or rather the v's. So we start off with our sine of x. And now let's take an integral of that is cosine of x, but we got to account for this negative. And then we'll integrate cosine to get sine. That negative sticks around. And then we integrate sine to get cosine, but now the negative is going to go away. And then we integrate one more time to get the integral of cosine is sine. So now you notice that u, v, that's going to be u right here times this one is v. And then we're going to subtract the integral of v du. But the next time over, it's going to be this one. And so this one is going to be a plus sign here. But then we're going to subtract this one. And then we'll go across this one, and it repeats itself. And then this one will give us a minus. So really, we have x cubed sine of x. And now we have this minus here from that. And now we have the 3x squared times negative sign. So let's make that a plus. And then now we're going to have a plus 6x cosine of x. And then minus, it's going to a new line here because of this minus 6 sine of x. And then, of course, we have our arbitrary plus c here. So we can use the tabular method to keep track so that we don't have to keep making all these mistakes. There's almost no algebra to do in this case.